Okay, let's see about moments. Moments are a statistical measure actually. Moments are used are used to describe the variable characteristics in statistics to describe the variable characteristics in statistics. Okay. Why moments is because each moment has something to do with the measures of central tendency. Usually measures of central tendency are mean, median, and mode. Of course, apart from measures of central tendency, measures of dispersion are also there. What are measures of dispersion? Like your skewness and kurtosis. Skewness and kurtosis moments are used to decide whether the data is positively skewed, negatively skewed, or not skewed like that. At the same time, kurtosis, whether it is platokurtic, mesokurtic, or leptokurtic, it's used to moments are used to describe or measure whatever that of the measures of central tendency and measures of dispersion. Now, coming to the types of moments that we have, actually, they are classified into 4 to 5 types. But let me talk about those which are very much useful to decide the skewness and kurtosis. More important ones, let me talk about, and then come to the generalized moments. Okay, types of generalized moments. Okay. First one I'm talking about here is moment about an arbitrary point A. The second one would be moment about mean x is equal to x bar. Now, about an arbitrary point A, first thing is to understand or to do any problem, first thing we ought to know is the definition about it. If you have the proper definition of it, and before proceeding further, if you check the proper definition of any problem or any topic, then you can proceed with the conceptual things in a more proper or strong way. Okay. How is an rth moment of a variable x about any arbitrary point x is equal to a bar? How is it defined? Denoted by mu r prime. Mu r also is there, which I'll talk about a little later. But mu r prime we are using because they are about the arbitrary point. Okay, mu r is also there. Mu suffix r is also there, which is defined to be 1 by n summation fi xi minus a power n. Okay, where summation fi is nothing but the sum of all the sum of all the frequencies. Okay, yeah. I can also call xi minus a to be some di, deviation usually. That's why deviation. Mu r prime can also be rewritten as summation fi di power r by n. Let's see how to consider the first moment and all that. Let me take first r is equal to 0, which is very trivial and easy one. Mu 0 prime would be 1 by n summation fi di power 0. Anything power 0 is 1. So it is nothing but summation fi by n. It is nothing but summation fi by n. Both are same. So this value would be equal to 1. Mu naught prime is what? 1. Now coming to what is mu 1 prime. Let's talk about what is mu 1 prime. For r is equal to 1, how will mu 1 prime be? To understand the definition, moments are easy. Otherwise, if you look at them, you write and look at them, they are such a lengthy things, and then it's very difficult to remember the prefixes, suffixes, powers, and all that. Okay. Xi minus a. Okay. So this is equal to, I'll just expand it, is equal to 1 by n summation fi xi minus 1 by n summation fi into a. Okay, of course, a is a constant. Summation fi is n. I can take out a. Okay, and this one is nothing but summation fi xi by n would be nothing but this value is nothing but x bar minus a can be taken out. Summation fi is nothing but n. N by n would be 1. So it is x bar minus a. A is the arbitrary point. So how do I define mu 1? Mu 1 prime is nothing but x bar minus a. Okay. Just box this. Before getting into different things, just box this. Yeah. Now, how do I talk about moments about mean? Let me talk about moments about mean. Okay. And then correlate both of them. Moments about mean. Mean x is equal to x bar. Okay. Yeah. Rth moment. How do I define it as? Rth moment. How do I define? Just let me write it. Because there's a difference in the notation. Rth moment. As I was telling, the prime is used for the arbitrary point. Okay. About the mean, it is just mu r. Mu r is equal to 1 by n summation fi xi minus, instead of a, it is the mean. So I can write mu or I can write x bar. Same formula. There's a change in the notation just to show that x is equal to x bar. It's not prime. Mu r is equal to 1 by n summation fi xi minus x bar power r. Okay. Of course, I can call xi minus x bar to be zi. Okay. And then rewrite it to be in a simpler format. 1 by n summation fi z power r. Okay. Yeah. So if r is equal to 0, what happens? Let us see. If r is equal to 0, mu 0 would be 1 by n. Anything power 0 is 1. Summation fi. Again, this mu 0 also is 1. So mu naught or mu naught prime, both are 1 only if you observe. Next, coming to r is equal to 1. Mu 1 is 1 by n summation fi xi minus x bar. For a shorthand notation, I can use zi, but I don't think there's any use of writing zi. Okay. 1 by n. I'll be having summation fi xi, which is x bar, minus x bar into summation fi by n. You can observe here, almost both the values are same. That is, first one is x bar. The next one value is also x bar with a negative sign. This is 1. Summation fi by n is 1. So this value is 0. So first moment about mean, mu 1 is equal to 0. What's it? First moment about mean. If you remember this, moment about mean is 0. Okay, if you remember this, instead of calculating, when you are asked to find the moments about mean, if you remember this, you can just directly write for any value, for any data, the first moment would be 0. Okay. Yeah, you can as well check with the second and other moments. Just for your information, I'll be doing second moment as well. For r is equal to 2, it is mu 2 is equal to 1 by n. You can check with the remaining moments as well. Actually, there's a one generalized formula in terms of the binomial coefficients, which I will tell, okay, a little later. But then mu 2 is nothing but this is equal to 1 by n. I'm sorry, this is 1 by n. Yeah, I can observe clearly that this value is nothing but variance, right? Yeah, mu 2 is nothing but variance. Mu 2 is nothing but variance or sigma square. Square root of a variance is standard deviation. Square root of standard deviation, square root of variance is standard deviation. Okay. Square of standard deviation would be variance. Okay. So mu 2 would be what? Variance. First moment is first moment about mean is 0. Second moment would be nothing but variance. Of course, in the next video, let us see how to find the relation between moments about origin, moments about arbitrary point, and moments about mean. Okay.